so we are looking at conditional probabilities, and it's red, this little symbol here, the probability of A given B. And what we're talking about is, given that B has happened, what's the probability of A? And this is different than just the probability of A, and we're going to use this in our rule for multiplying probabilities in a second. So the probability of A given B, let's just make up some probabilities here, okay? So the probability that A and B both happen is 0.4, and we'll make this be 0.3, so this is a total of 0.7, and this must be 0.3, and we get a 1, and let's make this 0.1 and 0.2. So there's 0.5. 0.5. All right. So the probability of A given B. You ready for this? So given that B has happened, we're only allowed to look in this column. This is like the given B column. Do you see that? Given that B has happened, I don't care about the not B's. I don't care about these 30%. I'm saying given that B has happened, I'm locked into this column right here, this row, and we say, okay, the probability of B happening, so this is the probability of A given B, is the total is only 0.7, because given that B happened, probability of B is 0.7. Now, what's the probability that A happened given that B has happened? So we need to look at this 0.4 out of 0.7, which is the intersection of A and B, and we get 0.4 out of 0.7. And you can get a decimal for that. Notice how it's different than the probability of B given A. The probability of B given A, we're saying, well, given that A has happened, given A, that's only happening 50% of the time. Now, what's the probability that B happened, given that we know that A happened? Well, 0.4 out of 0.5. And these are clearly different fractions because they have the same numerator but different denominators, okay? And so you need to be careful when you're reading this, and I really think that a two-way table is the easiest way to read this, because given A is really just focusing you in on the A column, and given B is really just going to focus you on this given B column. You just focus in on those probabilities and say, okay, what's the probability of A given that we know B has occurred? Okay, and so B occurs 70% of the time, and A happens 40% of those 70%. Okay, all right. Then let's do an example. All right, so the probability of liberal arts is 6,300 out of 10,000. And we can cross off those and we get 0.63. All right, liberal arts, and they earned an A, 2142 out of 10,000, which equals 0.2142. Okay, what is the probability of earning an A? Well, we can calculate that too. That's just A, 3392 out of 10,000, which is 0.3392. Now, what is the probability that you are in liberal arts given that you got an A? So given A, we're focused in on just these A's, and my denominator is now going to be the total of A's, 3392. Now, what's the probability that you were in liberal arts? 2142, okay, which is about 1/3. 2/3, I mean, okay. What's the probability that you got an A given that you are in liberal arts? So given that you're in liberal arts, now we're looking at the table this way, and we're saying, given that you are a liberal arts major, what's the probability that you got an A? Now, all liberal arts majors are these 6,300. What's the probability that you got an A is 2142, which is approximately 1/3. Okay, so the numerator is the same because there's liberal arts and A happening. A and liberal arts happening, 2142. But the denominator is, given that you're in the A's, what's the probability? Given that you're in the liberal arts, what's the probability? Okay, and so this idea and this idea, people tend to mix up, and these two ideas, people tend to mix up. But given A, that's the probability of A. Given arts, that's the number of people that are in arts, okay? This one we're doing counts. You can do it as probabilities or counts. We defined it here as the probabilities, but you can also do it as counts if they're equally likely outcomes, all right? This leads us to the general multiplication rule, okay? The probability of A intersecting B is not just the probability of A times the probability of B, it's the probability of A, right? This is what we're tempted to do, multiply probabilities. But this is only if independent, okay, is the rule. Because if A happening causes B's probability to change, then I don't want to just take B's generic probability. I want to take G's probability given that A occurred. Because if I'm having A and B both occur, then we let one event happen and then say, all right, times the probability that the other event happens given that the first event has happened, okay? So if they're linked in some way, if they're not independent, if they're associated, then we need to make sure that we're counting this, okay? Probability that B occurs given that A occurs. So this is, if they're independent, this is the rule for associated events, any two events, okay? So it seems like common sense if you think about this. 29% of internet users download music files. 60% of downloaders say, I don't care if it's copyrighted. The percent of internet users who download music, event A, and don't care about copyright, event B, is 67% of the 29% who downloaded it, okay? So 67% of the downloaders, given that they're downloading, okay? Of non-downloaders, right? Because there's 71% who don't download. Don't download. I would imagine that a lot of them don't download because they do care about copyright. And you would say maybe only 10% say, I don't care if it's copyrighted, right? Maybe there's a vastly different population of the downloaders, okay? But because we can say now 0.29 is the percent, so what is the probability of that they are downloaders and they don't care about copyright, okay? And we'll say not care about copyright, okay? Not copyright. 29% download times the 67% are the people who don't care about copyright given that they download. Okay? And that would get us our overall probability, which I don't have the number memorized. So you can multiply that in a calculator. It's going to be about 0.1. All right? So good luck. Conditional probabilities. Have fun. See ya.